right, so continuing on with the OSI model, okay, as you can see, as I was talking about before, as our data will sit up here, okay, and each one of our headers will actually be encapsulated from the previous header or the previous actual layer, okay? All right, as you can see here, this is our data, okay, with all the headers on there, okay, and actually at the bottom transmitting the bits onto the wire, okay? All right. Now, as I was saying before, as the communication goes from our source PC, okay, which would be PC1, and over here would be PC2, as the data is being created to be sent, okay, all these layers have to be built. As it gets put onto the wire and transmitted over to PC2, and PC2 receives the data, okay, all right, as PC1 builds the data, we're starting at the top and adding each one of our headers. As PC2 receives the data, okay, it's going to actually only see the layer 2 information, okay, and to get to each layer before it or on top of it, it has to strip the header off or strip the encapsulation. That's why we call it encapsulation, is because we can't see anything past that layer unless we strip it off. And the only reason why we're going to strip it off is if the data is meant for us. If not, if this MAC address was not the destination MAC address of PC2, PC2 is just going to drop the packet. It's just going to destroy it, okay? Now, not only do we have an OSI model, we also have a TCP model, okay? All right, or TCP IP model. And we also got to understand this is not the only model out there. Okay, anyone who's actually building any type of infrastructure, architecture of software, or any type of system or platform, most likely will have some type of model if they're not following the OSI model or TCP IP model. Okay, all right. So I just wanted to make that clear as far as exactly really how the OSM model is used as far as a means of troubleshooting from our perspective as we communicate with other engineers, okay? All right, talking about the layer 2, the layer 3, the layer 4, all right? Never have I ever said, this is a layer 5 problem. Okay, so as a network guy, I'm only focused on layers 1 through 4. Okay. Now, if a session is not being built, okay, most likely I need to go back over to the TCP IP session, okay, where my layer 3 or my, three-way handshake, which we'll talk in the next video, you know, and figure out why that's not happening. Okay, but never I'm going to say it's a layer 5 problem. Okay, all right, never am I going to say it's a layer 7 problem. I'm going to say it's an application problem, right? Okay, so it's just that's just me. That's just me. Okay, and that's normally what I see out there in the field. Now, last thought. Okay, if anyone doesn't know what a mainframe is, let me tell you that's way back in the day, and mainframes are still out there. Okay, so I need you to start getting this concept out of your head that things are dead. Okay, things just don't disappear because you work in an organization that is always rebuilding, always getting new technology. Okay, that's what they're doing. All right, it does not mean an average company does this. All right, okay, there's still software out there where there is no graphical user interface. It's just tabs and keys and enters and when I mean keys, arrow keys, okay, and text being typed in, okay, nothing but text on the screen, okay. So you need to understand that being dead, things just don't die, okay. There's always someone out there, okay. Right now at this moment in time, someone is out there using RIP as a protocol, okay. All right, so they might not teach you RIP, which I always do, because you never know. All right, remember, I'm teaching you a skill set. You never know, okay, if you ever come across a RIP protocol, All right. You're not going to just go into an organization and say, we got to rebuild. Okay. First of all right, you need to understand what your concept of, okay? Being complicated doesn't mean that it must be done. Overthinking a process isn't what your job is. Okay, being efficient and doing the simplest things to make the problem go away is the easiest and most productive way of making things happen. Okay, I do not want to go in and redesign someone's routing protocol just because I feel personally that routing protocol is dead. Okay, all right, it's just not practical. Okay, so if you go into a RIP environment, you should know RIP in a sense where you at least are not going in blinded. Okay, all right, yeah, you can do your research, but learning a protocol from scratch when you're getting paid by the hour on an actual situation, yeah, it happens. Don't get me wrong. Okay, it does happen. Sometimes you got to go out, all right, and you also got to understand everything's a network problem. Okay, everybody and their mother and father blames the network. And you'll start realizing how important capturing data is, and you'll start to understand that your network, as far as a engineer perspective, you go way beyond the concept of just networking. Okay, I have sat there and analyzed someone's protocol to the point of reading up exactly what the protocol does from scratch, deep dive, okay, to understand how that protocol is working, just to prove to them, okay, because that's usually what our job is. 9 times out of 10 is to prove that it's not the network, that it's the application. And you can't just tell them it's the application. You got to have proof. Okay, and it's you that does that, even though they're application guys, and those application guys should be the ones doing the work. Okay, all right, but they already got it in mind that the network is the problem, and it's always the network. Okay, so from that perspective, just, as always, be strong, be determined, be Cisco.